are going to start talking about equations of circles today, and so this is going to be the equation of circles. We do have our little squares. Make sure that you see those up there. They're a little hard to see, these little squares there. But more importantly, we're going to be looking for the radius and two values for our center. Our center is labeled HK. I'm not too concerned that you know what HK represents, because as you further your studies in mathematics, HK is going to represent other things. But for a circle, it represents the center of the circle, and R represents the radius. So let's take a second, because on Friday we're going to go to the library and do our breakout box, and you need to know what a radius is. So someone tell me what a radius is. What do you think, JC? Whoa, JC. I don't like his definition because he didn't raise his hand. What did you say? What do you think? That's beautiful. So you start at the center. It's a distance. It's a length from the center to where? Not outside the circle, but on the actual circle itself, right? So if I was going to draw it, we have a circle with a center. And wouldn't this be the radius? Yeah. Okay, good. What's the diameter? The full. So if I went all the way across, that would be 2 R's, right? So 2 R's would be the diameter. Would you agree with that? Okay, you've seen that before, I hope. Okay, just some vocabulary. So one thing I want you to notice about your formula is we do have some parentheses that are around the y and the x. We have some numbers, but we also have these minus signs. Do you agree? And when you learned about negative numbers back in the day, didn't it mean add the opposite? The opposite, right? So we're going to keep that idea here, because when we put numbers in here, we're going to keep that idea of opposite. So just hang tight for a second. Ready? All right. So here is example 1 that I want you to put in your notes. And here is the formula, or the equation, I should say, because it has numbers in it now. And we are eventually going to graph it. So if you have it on graph paper, awesome. If not, we'll just sketch the graph. But notice I have numbers in for H, K, and R. Do you see that? And I want to be able to graph the circle, but I can't do that until I figure out what the center and radius are. So let's make those decisions. The center has what coordinates, looking at the equation? Well, we're going to use the 3 and the 5, but we have to be careful about our signs. It's going to actually be positive 3 and negative 5. Because it says in the formula, it's the opposite, doesn't it? Does that make sense? You're going to use the opposite values that you see in order to do your center. Not for circles. How about the radius? What's the radius? Here's a hint. It's not 16. It's not 8 either. So be careful. Look at your formula. What does R squared equal? Oh, so it'd be 4. There you go. R squared is 16. Don't you agree? R squared is. But to find R, don't you have to take the square root? So what's R? Cameron was right. R is 4. Okay? The radius is going to be 4. So we can use our center and our radius to actually graph this. So what we'll do is we'll start graphing the center. What quadrant is the center in? Think back to algebra. Not the first. Remember our quadrants, 1, 2, 3, and 4. The 4th quadrant. Good. I'm going to start with a positive x value of 3, and I'm going to go down 5. So here is the center of my circle. Doing okay so far? By the way, we name circles by their center. So if I called that point W, this would be circle W. If that point was Z, it'd be circle Z. Just it's how it's named. Okay? Now, how can I use the radius to find points that are actually on the circle itself? Well, from the center, didn't JC say it was from a point from the center all the way out to the circle? So my radius is 4. So what if I went up 4, I went down 4, I went left 4, and I went right 4? And I just connected all of those dots. So because I have a smart board, I'm going to use it, and I'm just going to graph the circle. But you can just connect them with your hand. That's just the circle with that equation. Now the reason, Sanaya, we can't plug this in my calculator is because if you look at your y equals, it's solved for y. It says y equals, and you can plug it in. This is not solved for y. It doesn't say y equals. I can't plug it in right now. There is a way to do it, but it's a little beyond our scope. Any questions so far? What if I gave you the graph? Could you write the equation? Let's try it. You don't have to write this down, but I would like us to try looking at a picture. How could I write the equation of this circle? Let's think about the formula. The formula says this. Well, I have to plug in the center and the radius. Do you agree? That's the formula. You have the formula written down. How do I find, which one should we find first, the center or the radius? Why? We have to find the center first. Why? Well, we don't, almost, yes, we're getting there. Think about what JC said. Radius was from the center to the outside of the circle, right? We don't know what the center is yet. Got to find that first. How do I find the center? So Miss Penny's eyeballing it, right? She'd say, well, it's somewhere about there? No. Somewhere about there? No. Let's find out exactly where it is without eyeballing it. What we can do is we can say, well, let's draw this diameter in. Let's draw this diameter in. And then where those diameters cross is going to be the center. Would you agree with that? So what are the coordinates of my center? Over 4 up 2, which is what as a point? How do I write that? 4, 2, right? How do I plug those numbers into my formula? So we want them to be the opposite, so well, I'm not going to plug in a negative 4. It's already minus, right? So 4 and 2. I don't have to change any signs. How do we feel so far? Yeah? I still have a number over here, Omar. Come on, Ethan. It's not 10. It's not 5 either. Well, it would be 5 squared. Yes. Where'd the 5 come from, Liba? We shall eventually be 25. Yeah, so we just, like JC said, you count from the center out. So if I count here, 1, 2, 3, 4, 5, the radius is 5. The formula says 5 squared, though, doesn't it? And so Sanaya's right. My final answer is going to equal 25. I agree. Very good. Yeah? Takes a little practice. Not too bad. All right, let's try something else. This, by the way, don't write it down. This is a released SOL question from years ago, but it's pretty quick. So it's a multiple choice question. Let's figure out what we think the answer could be. Don't yell it out, but look through it and tell me what you think the answer could be. Don't yell it out. Don't yell it out. Give everybody a chance. Mikey, what do you think? It is C. Very good. Because we know that my center is here, which means if we're putting it into the formula, don't we looking at the opposite signs? So we're going to say positive 4, x plus 4, and y minus 1. By the way, this is the reason that the -4 exists. When you set that equal to 0. Don't worry too much about that, but there you go. All right, how are we doing so far? We're good? All right. This is our last, this is example 2 that I want you to put in your notes for me. I am going to cover up the last parts because that one is a little bit more difficult. But I want you to put this example. We're going to get to that question D next class, probably after our breakout in the library. We'll see. They are, yeah. Sure. Sure. Yeah, the squares I wrote are little. I'm sorry about that, Cameron, but there are squares in there. But not with the 25. So this time I gave you the equation, and I want us to figure out what the radius, diameter, and center are. Elizabeth, what do you think about the radius? What number am I going to use to help me find it? Perfect. So 25 is what I use. Now the radius is not 25. What is 25? What is it? Look at your formula. What does it say in your formula? R. In your original formula that you wrote down, R squared, right? So R squared is equal to 25. How do I actually figure out R? Square root. So that becomes just 5. Very good. What's the diameter, Hosea? If the radius is 5, it would be 10, because it would be twice the radius, right? Very good. Awesome. Make sure you realize that, because those are some of the questions in your breakout box on Friday, is the relationship between the radius and the diameter. Good. How about the center? -3, +4. Very good. You guys got this. This is good. I'd like us to look at one more question that is from the SOL, but it's actually on TestNav. So I'm going to pull it up. And this question, I pulled it up. I will turn the lights out so we can see it. So you don't need to write this down. But look at how this question is read or written. So read it to yourself. What looks different about the equation than the ones we've seen so far? Yeah, there's no parentheses with the x squared. Do you see that? So I'm going to write it off to the side, so if you're listening, you won't be able to see it. But x squared is the same thing as x minus 0 quantity squared. That means the same thing, okay? So it's just another way to write it. So my question becomes, what's the center of the circle? Look at your equation. 0, 2. Awesome. Now, go ahead. So who wants to come up and try to plot it for me? Go ahead, Cameron. Plot that point. I'm hoping someone plots it wrong, and I'll tell you why. All right, go ahead and try it. Try it and see if you can get it wrong. Because there's a mistake, and I'm kind of purposely hoping someone makes a mistake. Just with your finger, sweetie. Just go ahead and hit it. The center. Any way you want. All right, fine. Perfect. Thank you. That's actually not the center, but that's perfect, okay? You just told me the center was 0, 2. Do you agree? What did he plot? 0, 0. Notice a couple things, and there's a reason why I pulled this up in TestNav. Do you guys see that blue like halo around the point? Okay, that doesn't mean anything. What that blue halo is for is because the people who wrote TestNav or the program know that you might take this on a tablet. You might take your SOL on a Chromebook or on a Kindle or on an iPad. And so that is going to be the circle parts about the width of your finger. Jamie Lynn, if you'll put your phone away for me, that would be awesome. So that's just like your finger. That's all that means. Don't let that blue halo fuzz thing bother you. Now, if you read the question, it says I need to plot the center and another point. Do you agree? Where is the other point supposed to be? On the circle. So if I wanted to plot the actual point, ooh, now it has two circles. I wanted to move my point. So what should I do with the one that was originally graphed? You actually just hit it again and it goes away. Okay? Because it will plot 2 points at a time for us. So just be careful with that. Okay? Is that the correct center? 0, 2. How do I plot another point that's on the circle itself? But I want to keep that because that's the center. What do you think, Liba? The radius is 5, isn't it? Isn't r squared 25? So what's r? 5. So where should I go? Up, down? You have 4 possible ways to graph this problem. So if I go up 5, that would be one way to enter my answer. The center and the point on the circle. What if I decided to go down 5? Notice that the center stayed the same. It was just moved the other point, didn't it? What if I wanted to go left 5? Or if I wanted to go right 5? Any of those would work. But if I wanted to take the point away, I have to hit it. Does that make sense? Okay. So I wanted to show you that, okay, because I think that's important. Let's go back now to this question. Let's now add this. Is the point 2, -1 on this circle, or would it maybe be inside or outside the circle? What do you think we could do to figure the answer out? Let's start by graphing it. Love it. Let's graph it. I like that. So we're going to start at the center of -3, 4. I'm just going to estimate it, okay? So 1, 2, 3, -3, 4. And then what am I going to do to finish graphing? What's my radius? It's 5. So 1, 2, 3, 4, 5. And then if I went to the right 5, so 1, 2, so that would be right 1, 2, 3, 4, 5. There we go. And then we could go down 5. And I'm just going to kind of estimate. It looks something like, and it goes like, I don't know, whatever, pretend. Okay? The point 2, -1. Doesn't it look like it's outside the circle? Okay. So we can estimate it with a graph. I love that. But sometimes the point is so close, it's hard to tell. So you betcha there's a way to prove it algebraically. Algebra. You guys did this kind of thing before. You'll see. If you look at my equation, what can I do with the number 2 and the number -1 in the equation? What do you think, Liba? Yes, this is x is 2, and y is -1. Plug it in. If it was on the circle, what's going to happen on the left and the right? That's right. So let's test it. Let's see. So we have 2 plus, and you have calculators. Just plug them in. 2 plus 3 squared plus y minus a -1. Oh, not y. I apologize. Y is -1, right? -1 minus 4 squared. Does it equal 25? Plug it in. Nike, plug it in. Omar, plug it in. Left and right. The right's 25. What does the left equal? Where's your, come on, Hosea, go get your calculator. It's definitely not equal. What does the left equal, though? It should equal 50. Are we okay with making sure you plug one in as a negative and one in as a subtraction? Make sure you're careful with that, right? We learned that in algebra last year. I want you to make sure you know how to plug this in and get 50. So I get 50. Does it equal 25? No. It's bigger than 25, isn't it? No. That means it's outside the circle. Last part of your notes. Are you ready? Mm-hmm. Yes. It's like, it doesn't have 25, like if it's a smaller number, would it still be inside? It'd be inside. So we're trying to figure out if the two numbers, this should look familiar to you, by the way. Acute, obtuse, right triangle kind of thing with a greater than, less than. If it's equal to it, it's on it. Yep. So if it's greater than, it's outside the circle. You should write this down, by the way. It's outside the circle. If it's equal to it, it's going to be, no, on it, on the circle. And if the radius is bigger, squared, that's going to be inside the circle. And honestly, if you look at your picture, now I know these numbers are squared, but just think about it from a visual for a minute. The distance from here to the point, isn't that bigger than the distance from here to here? So isn't the radius smaller? Isn't that what we said? I know the numbers are squared, a little different, but that's why we know it's outside the circle, if that helps you visually. All right? But I definitely want to make sure you have this in your notes. Okay? We will practice more of these types of questions after our breakout box on Friday. All right? So to make sure you have good notes to refer to when we do our breakout.